Hello, so in this video we are going to talk through some different ways of how to bring data into R. Now, first things first, there's lots of different ways in which you can bring data in. And I guess the reason why there's lots of different ways is because it really depends on how your data is structured, okay? So knowing a little bit about how your data is structured will really help to work out which of these options that I'm going to show you and I'm going to explore with you works best for you. So let's start off with an example then. Let's suppose I've got this data set here, and at the moment it's stored in an Excel sheet, okay? So you can see that each column of my data represents a different variable. So I've got letter in my first column, type in my second, and size in my third column. Then each row basically represents a new entry into my data set. So here's an example, that row there would represent a letter, which is 26, the type is A and the size is L, okay? And then the next row would represent a brand new letter, letter 30, which has a type of A and a size of L, etc, okay? So each row represents a new data set, new data entry, and each column represents what that variable of that particular data entry is going to be. So if this data set is relatively small, or perhaps a naive way of doing this would just simply be to manually type your data directly into R. Okay, so if I just pull this across, okay, if I bring up RStudio here, you can see that I've already brought up a new script. Now, just a reminder, the way which you bring up a new script is by coming up here, you notice there's a plus, clicking on the plus and clicking R script. So here's my R script, okay, and I'm just going to start off just simply by typing these values into a vector, okay? So I'm just going to start off by calling it a name. I'm going to call it values. Just remember, you can call your vector whatever you like, as long as it's not a predefined R command and it's not starting with a number, okay? So values is totally fine. I'm going to assign it using less than or equal to, and I'm going to create a vector, so I'm going to concatenate it, okay? I'm going to C bind it. So I'm going to put a C at the front and obviously open and close those brackets to put my values in. And all I'm literally going to do is I'm just going to work across. I'm going to start in the first element, then the second, third, and then I'm going to move on the next row. That'll be my fourth, fifth, sixth. So I'm just simply going to type it. Now, are you happy that letter, type, size, AL, these are all types of characters? So in which case, whenever I type a character entry in my data set, I'm going to need to put it in quotation marks. So let's do the first one, okay? Let's do letter, okay? Now, to separate each element of my data, I'm going to use a comma, okay? So my next one is type, my next one is size, okay? My next entry, so I'm now on the second row, is going to be 26. This is a number, okay, and I want R to read it as a number rather than as a character, so therefore I can just type it as a number, okay? And then the next one, so I'm going to go A, the next one is going to be L, and so on and so on. So here I have my data stored, okay? So basically I've created a vector called values, and I've basically just written all my data out, just a single long vector, okay? But the issue is, if I just run this particular section of code, so I can either run a script file either by clicking source or by run, so I'm just going to click source, okay? You can see that that vector has appeared over here in the environment, the global environment, and also if I click down here in the console and just get it to print values, you can see it pulls up that data. Now, even though R has kind of written it on a new line, that's just because of the size of the window, okay? So basically, at the moment, it's storing it as a single long string. That's not what I want, because look how my data is stored. It's stored with columns and rows, and it kind of makes sense it's structured like that, because obviously each row represents a new entry. So in order to get this to work then, what I'm going to do is to convert this vector, this values vector, into a matrix, okay? So I'm going to give it a name. I'm just going to call it data file, okay, just as my name. I'm going to assign it, and I'm going to use the function matrix. Now, I know we have talked briefly before about the difference between matrices and arrays, so please feel free and go and look at those videos if you're not sure. Essentially, a matrix is like two-dimensional, so rows and columns, okay? An array, it can be as many dimensions as you like. So you don't just have rows and columns, you can have like three-dimensional things or four-dimensional things as well, okay? So let's have a look at converting a matrix. So first of all, open and close my brackets. I need to tell R what data I want to convert into a matrix. So in this case, I want to use this values vector, okay? These elements down here in the console, okay? I then need to tell it how many rows and how many columns which I want. Well, let's see. How many rows and columns have I gone for? Well, I've gone for 5 rows. So I'm going to go n row equals 5. That's the number of rows. Then comma, I'm going to go n col for the number of columns. Well, in this case, I just want 3 columns. So 1, 2, 3. Okay. So let's have a look at this and let's see what we get. Okay, so if I just go source, you can see that if I come down here, data values has been stored. So if I go data, file, click enter, and you can see this has now been converted into 5 rows and 3 columns. Now, the issue is with this, you notice that the way that R has filled my matrix is it's filled going along the columns. In other words, it's taken the first element, which is letter, it's then gone to the next row and put type, gone to the next row and put size, next row 26, and so on and so on and so on. So it's basically working down. Okay, it's working down the columns, and then it goes to the next column and the next column. That's not what I want. I want to fill it by the rows instead. So all I do is just come up to my data file, add another argument, which is by row equals true. Okay, so by default, it will fill it by the columns. In this case, I want to fill it by the rows. So I go by row equals true. Now, one really sort of obvious question which I get asked quite a lot is the difference between run and source. So you see at the top of my script file, I have run and I have source. The difference is effective. The run basically just runs that particular line or lines that I've highlighted. So you can see that my cursor at the moment is on this line 2 of my script file, which means if I click run, it will only run line 2. Okay, whereas if I click source, it will run every single line in my script file. So sometimes it's useful to use source because it runs everything in your script file. Sometimes it's useful just to run a particular section. So if I just want to highlight and click run, or perhaps just put my cursor on a particular line and click run, it will just run that particular section of the code. Okay, so now if I come down here and if I type data file, you can see that I get this data file structured exactly how I'm supposed to. So if you look in the R console, you can see it's structured how I want it. Okay, so that's really handy. So the thing is, this is fine. This is a very naive way of getting data into R. Particularly if your data set is very small, it is fine just to type it in. So maybe just bring it in as a vector and then converting it to a matrix, an array or something like that as appropriate. But I don't want to do that because look, my data has already been structured. Okay, my data has already been structured how I want it. And look, I've got sort of over 100 rows that I want to pull in here. So because my data is here, I don't want to have to keep typing it manually every single time. So actually, I'm just going to get rid of this, okay? Because I don't want to do it like that. There's a much better way of doing it, okay? So the way which I'm going to do it instead is I'm going to tell R, first of all, where to find my data files. So if I bring in my directory here, okay, now I've got lots of different files here. I'm actually going to use one of these first. So they're just basically different versions, and it'll become clear why I've got different versions in just a second. But effectively, my data is in this particular folder. Okay, so I found my folder in my directory. Now, if you're on a Windows machine, it's slightly different on a Mac, but I'm going to talk through a Windows machine on the basis that it's a very similar principle on a Mac. If you come to the top of this bar up here, so you see up here that I've kind of got this this bar along the top here, and if I right click and go copy address as text, what that is effectively going to do is it's going to bring in exactly where to find my particular data in my directory. Okay, so I just stored that address as text. I can then come back to RStudio. I'm going to give it a name, so I'm just going to call it main folder for me. Okay, I'm going to assign it, and then if I just go Control and V, it basically brings up the address. So basically, it tells R which directories to look in until it finds the appropriate file. Okay, so one thing that you need to do here is you need to turn these backslashes into forward slashes. Okay, it's the only annoying thing about doing it this way. R reads a new directory as a forward slash, whereas obviously Windows, when I copy and paste it, it will bring it in as a backslash. So just make sure you change those backslashes to forward slashes. Also, because my data is found in this folder in lab 1, the last kind of directory to look in, I need to tell it to go one directory deeper. In other words, actually find the file from here. So I'm just going to stick a backslash on the end. Now, because this is a text string, okay, rather than a label, I'm going to put all of this in quotation marks like so. Okay, so that's how this works. So this is my main folder. Now, good practice now is to actually say to R, look, I don't want to have to define that folder every single time, okay? So what I'm going to do is I'm going to set my working directory to be this particular folder, okay? Now that means it's good practice because then that means that all of my data is going to be called from that particular directory, that particular location, but it also means that anything I do now will also be written to that new directory, okay? So it means that I don't have to keep defining this address every single time. So there's a couple of ways you can set the working directory. Number one, you can come to Session, then set working directory and choose the directory that way. Or you can do it by the command line. So just go set WD, so set working directory, okay? Open and close your brackets. And then I need to say, look, this particular string here is my main directory that I want to look in it. So anytime I basically call a file, anything below this point, if I call a file, for example, this particular file, it knows, R knows to look in this particular directory, this particular folder, okay? So let's have a look at this then, okay? So let's work out, first of all, how we can literally call data in. So let's work out which data do I want to call in first of all, okay? Well, let's first of all call in this particular data set here. So if I open this up for you, okay, this particular data set called letter data underscore and, you can basically see that your data is being called in. So this is your data which you want to call in, okay? So what I'm going to do is I'm going to call it data file. I'm going to give it a name, so that way I don't need to call it in every single time. Just give it a name, then it will get stored in this particular variable or label, okay? I go less than dash to store it, and then I'm going to use the command read.table. Now this is the most useful command for calling data into R. So obviously I'm going to open and close my brackets. Now, the first argument is where my file actually is. So I'm going to go file equals, and because I've told R that whatever file name I type down here, I've told R, because I've set my working directory, to look in this particular location. So I don't have to then redefine it again. Okay, so I'm going to go file equals, I'm going to open my quotation marks because obviously this is now a text file, this is a name, okay, and I'm just simply going to type the name of my file. So I'm going to go letter data underscore and. So letter data underscore and. Now this is really important because what you must also add is the extension. So if you have a look, I want to call in this particular file and you see it's a text document. So by default, Windows will hide the extension, but actually it's called letter data underscore and then there's a dot and then the file name, the file extension, which is there. So in this case, because it's a text document, it's .txt. So you must make sure you put your extension there, okay? Now, there's a couple of other little sort of things that you need to put here. First things first, I need to tell R how my data values, so each value in my data set, is actually being separated. So if I just bring up my data set again, here it is, okay? So this is my first element, so letter is my first element of my data set, type is my second element, and size is my third, okay? And you can see that every single element of my data set is being separated with an and, okay? So in order to tell R how to distinguish each data value, I'm just going to go comma, then I'm going to go sep equals. So this is how my data is being separated. I'm then going to use quotation marks, okay? And I'm going to say it's separated with an and, okay? So now if I run the entirety of that code, okay, and if I want to view this data file, you notice it comes up over here in the right hand side on my global environment. There's my data. If I double click on that, you can see that my data has now been brought in to my into R, okay? Now there is one slight little issue here. You notice that letter, type and size, these are not actually part of my data. So at the moment, you see where it starts with row 1, R is basically recognizing that that's actually the first element in my data set, which it isn't, okay? In actual fact, I want this row to be the first entry in my data set, okay? So this needs to be the kind of the names, or if you like, the headers. So if I exit out of that, I can basically change where I've called in read.table. I can change this by adding in a new argument. Okay, so I go header equals true. Now what that basically says to R is that first row of my data set will just be the header. Okay, it's not part of my main data set. It's just basically telling me what each variable corresponds to. So now if I source that, you can see my data file starts with 26 AL, which is what I wanted, and the top is basically each element or each variable within my data set, which is exactly what I want, which is fantastic. So what about if I have another data set then? So basically this separator is the kind of really important thing, okay? This separator is going to tell me how to distinguish each element within my data set. So let's suppose I have a data set that looks something like this. So this is exactly the same data set, okay? But this time, each element is being separated with a comma. So all I need to do, very simple, is just change that and to a comma, and obviously it's a different file name, so I'll just quickly change that, okay? But the important thing is I've changed that separator now to a comma. Okay, so now if I go Control Enter, which is the shortcut for run that particular line, you can see that my data is still called in exactly the same way. Okay, so just basically that separator is telling R how to separate each element within that particular data file. Okay, now you may have a data file that looks something like this. So in other words, the data is being separated with a space or with a tab, okay? So in order to do that, in order to bring that kind of data in, the separator is with a space, okay? So in order to do that, I'm going to go / and T. It stands for tab, okay? This is a predefined command in R. It basically recognizes that each element in my data set is separated with a tab or with a space, okay? So now if I clear that, so I can clear my global environment just with that sweeping arrow, click yes, empties my global environment. I click source, set my working directory, etc., call the data in, and you can see that data is being called in the same way. Okay. So in other words, if you know how your data is being separated, whether it be with an and, whether it be with a comma, okay, or whether it be with a space, then you can basically use read.table, tell R where to find that particular file, tell it how each element in the data set is being separated, and then finally, whether that first row is actually just a header, okay, so it's not part of your main data set. By default, that will be set to false, okay, but most data sets, that first row, for example, this one, that first row is usually the header of your data, okay, so that's really important. Now, if you use read table, that is absolutely fine. So you've got your head around read table, okay, so here's read table. Right, you basically need to define the file name, you need to tell R how the data is being separated, and obviously any extra parameters which you may need there as well, okay? So read table is basically the way in which you bring data in automatically into R. But what if you have data saved in a particular format, okay? What if you don't want to have to define this every single time? Well, there are some different versions of read table. So read table is kind of the basic command, but there are some sort of slightly adapted or tweaked versions of read table, which basically has some of these parameters automatically defined by default, okay? So as an example, here I've got my data file, okay, and you can see that it's stored in an Excel spreadsheet at the moment. So this data is basically stored in an Excel spreadsheet, and each element is given by a new cell, okay? So as long as the data is structured correctly, I can basically go File, then Save As, and you see up here, I can use a drop-down arrow, and I can find CSV, which is comma delimited, or another way of saying that is CSV stands for comma separated values. So what that will do is I give it my name, I choose comma separated values, and then basically what will happen if I click save is that each new element in my data set, in other words each element in a different cell, will then be saved as by default will have commas separating each value, okay? Which then means that when I come in here, all I have to do then, so if I get rid of this, I don't have to use read.table anymore, I can just use read.csv. Okay, and again I can define my file, so in this case it's letter data, make sure it's in a quotation marks, okay, .csv, CSV, and in this case I just need to define my header, which is true, just to make sure that first row is definitely defined as headers of my data set, okay? But the point is, I don't have to define how my values are being separated because I know that it's been saved as a CSV, in other words, comma separated values. So by default, that's read.csv is effectively read.table, but with that command automatically filled. So it's basically the parameters have been just tweaked slightly to work better with pulling in CSV files. So the important thing to know is that some people say read.csv is different from read.table. Not really, it's not. Like read.table is still what's going on in the background. It's just read.csv has automatically filled in some of those parameters for you, such as how your data is being separated. Okay. Now likewise, you may have a data set that looks something like this. In other words, it's saved as a text file. Okay. So in order to do that, all I need to do is again just change CSV to read.dlim. Okay, so again, read.dlim works in the same way as read.csv in that it's still using read.table, it's just it's got some of those parameters, some of those arguments defined by default to work with text files, okay? Now obviously I'm just going to have to change my file name, so it's txt. And again, if I run that, it's still going to bring in my text file, okay? So really, my moral of my story with this is if you use read.table, it will always work. Okay, but there are some variations on read.table which have got some of the parameters or some of the arguments defined by default to make them work better, make read.table work better with those particular types of file. Okay, Now, there is actually one extra thing which I think is quite cool, which I want to show you. Okay, if I actually just bring up this particular Excel file here. So let's suppose I found a particular data set. This could be on a web page. In this case, it's in my Excel file. Okay, and I want to basically copy and paste this data into Excel. Can you do that? Well, yes, you can, okay? So let's suppose I just want to copy that particular section of the data into Excel, just to work on that particular section. So rather than having to go through the kind of read.table, import my data, and then kind of define to R, tell R which particular sort of section of the data I want to call in, all I'm going to do is just highlight this particular section of the data in Excel, go Control and C, or Command and Copy on your Mac computer, but effectively I'm going to copy this data, okay? Then if I come into R, what I'm going to do is read.table, okay, and I'm going to tell R that the file is found on my clipboard. So I'm going to go file equals, and I'm just going to use quotation marks and go clipboard, okay. Now in this case, my header I've included, so I'm going to header equals true. Now my point is, and just to show you that I have genuinely brought this in by copy and pasting, so I'll clear this this particular global environment. And if I press source now, you can see that what's basically happened is it just called in the data. It's called in the data which I've highlighted. And just to prove that's working, let's suppose I'll just pull in this particular section of the data instead. So again, I'll copy and paste this particular section of the data. Obviously in this case I haven't got my header, so I'll just quickly remove that. But again, if I just click source, you can see that my data file just pulls in that particular section of the data. Now that's really useful, particularly if you've got data on like a web page or something. You just want to particularly call in data from a web page or from a Word document or something like that. That's really useful. You just go Control C, and then basically you can just say copy it in from the clipboard. Okay. Now, just a word of warning that by default, it's kind of separated by tabs, by space. Of course, I can change the separator to be whatever I like. So I can change it to be tabs, I can change it to be commas, I can change it to be whatever I like, okay? This is the command for Windows, okay? So I'll leave this on here, but I'll just type this is for Windows. So if you're working on a Windows or PC, then this is the command you use. If you're working on a Mac computer, it's a slightly different way of bringing it in. So it's read.table. You've copied and pasted, so I'll go file equals. Okay, the way which I bring it in this case, you have to use a function in order to do that. So I'm going to go pipe and then open and close my brackets, and I'll go pb paste. Okay, so that's if you're working on a Mac or an Apple computer. Okay, so if you're working on an Apple computer, you use this command. If you're working on a Windows computer, you can just go file equals clipboard there. So that's really quite handy. That's one way in which you can bring data into R. Okay. There is also another way which you can do it. If you notice over here on the right hand side, there's an option for import dataset. So if you just use the drop down arrow, you can basically choose to bring it in from text, from Excel, SPSS, SAS data, etc, etc, etc. Okay, so you can basically bring in your data that way. Now, one way that you cannot bring in data is just by going File and then Open File. Okay, because if I do that, for example, if I want to bring in letter data, that particular data set there, you notice that all will happen is it will just bring it in as a text file. In other words, just like you would open up a code file or a script file in R, okay? This hasn't been stored to a data set, okay? So just basically been bring it in just a file, separate file, and it's not being stored as a data set. So you cannot just go File, Open File, okay? But as a general rule of thumb, that's the way to bring it in. Now you notice that I've just kind of used good practice here. So I've just said, well, look, set working directory. And then whenever I kind of define what particular file I want to bring in, for example, letterdata.txt, okay, then you notice that I don't have to define that particular location every single time. But of course I can do. I can get away without doing all of this at the top. So for example, when I do read.table and I've got my letter data, if I actually put all of the location in front of that, okay, and get rid of all of this, okay, and if I clear it just to show you, that is also fine. So if you just want to bring it in on one line. So that's particularly useful, particularly if you've got your working directory set in a different location. For example, that's where the majority of your data is. But then let's say you have one particular file which makes sense to be saved in a slightly different location. Then you can absolutely change the file just by putting the file kind of location in front of it and then just making sure you finish off with the name of that file there. So that would also work. Okay, so just be aware there's a couple of different ways of how to bring data into R.